Imagine that you're traveling to Africa to visit houses. You start from the city where you see aesthetically attractive and fancy houses. And then you move to the rural area where you see green and vernacular houses. If you end up staying there for a few days in a decent climate condition, and of course for free, you may think that those houses are incredible. But this is not true for people like me. My name is Binega. I grew up in Ethiopia, East Africa, where I was able to experience living in both types of houses. The city houses are resilient but not sustainable and affordable. Only 19% of the people can buy those houses. If you're living in rural area houses, they are sustainable and affordable but not resilient because they're affected by natural hazards like flooding and earthquake. So, how can you build resilient, sustainable, and affordable houses?
Imagine that you wake up in the morning and you see a house built over a night. Well, that's my PhD research. I want to 3D print a house over a night using sustainable materials that can resist both compressive and tensile loads. Therefore, my problem statement is how can we learn from historical construction to adopt affordable, sustainable, and resilient 3D printable houses? Well, for my mom, this may sound crazy. Using a remote control and 3D print a house layer by layer, like a cake. But it really is like a cake, baking a healthy cake with the right amount of ingredients. My motivations are ancient historical houses and 3D printing technology. Ancient people used materials that are available, sustainable, and affordable, like clay and hemp. And using 3D printing technology, we can afford less time, less cost, durability, and avoidance of formwork. Hemp concrete is a material made of hempcrete and coal in which both are eco-friendly and energy efficient. Well, I coined that word! Have you ever thought of this? 5 hempcrete walls rescue the environment by absorbing 1,500 kg of carbon dioxide, whereas 1 concrete wall pollutes the environment by emitting 1,500 kg of carbon dioxide. The objective of my research is to study the material science and design of hemp concrete structures and to modernize them to 3D printable sustainable house. The methodology of my research starts by proposing 4 phases. It commences with reviewing the ancient sustainable home building and ends with 3D printing a load-resisting structure. To achieve these phases, I started setting up my experiment consisting of printing robotic arm, raw material mixer, and pump. I ran several mix ratio tests. Once I achieved the best mix ratio of the material, I started 3D printing. Well, I wouldn't lie, my first trial was a mess. Although I thought the strength and mix ratio of the concrete was the best, it wasn't buildable enough via the 3D printing method. My second and third trials were okay, but were only 20% of what I've wanted to achieve. Therefore, I understood that I have to study the buildability of 3D printable hemp concrete as well. This took me to running more than 13 experiments using a handheld pump to study how buildable my mix ratio could be. Through all these experiments and trial and errors, the final result I anticipated was achieved. What is the final result? Can you guess? Well, it is 3D printing a half concrete wall. This wall is buildable since it was possible to achieve 3D printing up to 20 layers non-stop and with only 3% of deformation of each printed layer from the original layer size of 15mm height by 30mm width, which is an acceptable deformation for other materials. Therefore, to conclude my research study, the main takeaway is combining hemp concrete, it is possible to achieve a buildable 3D printable structure such as a hollow curved structural wall.
Ladies and gentlemen, the potential impact of my research is by modernizing the traditional sustainable earthen materials such as hemp concrete using 3D printing technology, we can build a sustainable, resilient, and affordable houses. Thank you.
I would like to thank my professor, Dr. Alimi Mari, for advising me through this research.